So as Roberta said, today I'll be covering the estimation of greenhouse gas emissions from the energy sector. I'm Diego Ruiz, I'm Energy Data Officer here at the Energy Data Center. Let me start. Okay, so brief overview of the topics I'll be covering today. First is the role of energy in global greenhouse gas emissions. Secondly, we'll be touching on two main international standards involved in the work estimating greenhouse gas emissions, the IPCC guidelines and the IEA. We'll then touch on the main methodology described in the IPCC guidelines. We'll also mention and insist on the relevance of data quality in the work we do at the IEA. And finally, we will touch on two topics on how emissions can relate to other metrics at national level, and we'll wrap up with some key takeaways and some Menti questions at the end. First, the role of energy in global greenhouse gas emissions. In the figure, we can see that both in 1990 and in 2023, energy plays a major role and takes major share in greenhouse gas emissions at global level, accounting for around 3/4. And this is very important in 2 points. First, in the relevance of keeping a well-structured accounting of the emissions from energy at global level, and also in the sense that given that it takes this big share, it's of course very relevant on how to fight these emissions and try to reduce them. The classification of sources for emissions by the IPCC guidelines is mainly separated in the 4 major categories you see here: energy, industrial processes and product use, agriculture, forestry, and other land use and waste. Here, and during this presentation, we'll be focusing on energy and specifically on fuel combustion activities. We're gonna move on to a short Menti question. To start, which sector was the highest emitter globally in 2023? I'll start. So if anybody needs to join, I'll give 2 brief seconds still, but normally it's the same code as before. Okay, we're still halfway there. Okay, I'm gonna give 10 seconds and we're gonna keep on and see the answer for this. Okay. So most of people were saying transport. but actually the biggest share of global CO2 emissions is power generation. Here we can see from 1990 we were at 40% share for power generation, and in 2023 it's a bit more, and on the right we can see split the quantities of emissions by sector. We can see that from 1990 there's been a much more considerable growth for the emissions from power generation, also industry and transport, and that for buildings and other categories like agricultural, fishing, the change has been much smaller. Of course, this is at global level, and this figure would vary from countries with much bigger energy industries. Of course, power generation would have a bigger share, and also transport, and countries where this is not the case would have more equally distributed shares. Moving on now to the two main standards we follow for estimating emissions. First, International Recommendation on Energy Statistics. My colleagues from Balances already touched on this. This is the reference for building the energy balances, and for estimating national greenhouse gas inventories. We follow the IPCC guidelines. These both standards are aligned, which means that energy balances collected or energy statistic collected under the IRES will be matched in order to follow the IPCC guidelines for estimating emissions. Here, the IEA has been taking an active role in the elaboration of both these standards. We'll now move on to methodology and the two main methodologies described by the IPCC for fuel combustion emissions. First one is the sectoral approach, which is bottom-up. So in this case, we would take data from the demand side, and we would need data both split by product and by sector. So this bottom-up, this much detailed approach, and this allows us to estimate all greenhouse gas emissions from fuel combustion. The second approach is the reference approach, in this case top-down. What we're going to do is take energy supply data and estimate emissions from this. So here we would take the supply data for each of products into the economy, and this will allow only to estimate CO2 emissions. Consideration for both these approaches is that you need to exclude the non-energy use of fuels. This would entail, for example, the elaboration of or the manufacturing of paint or other chemicals, for example, in industries, would not be considered. Now, I'll be covering each of the two methodologies a bit more in detail. For the reference approach, here we would take the total carbon input to the economy and take the consideration that this carbon will either be released into the atmosphere as CO2 or stored in products or fuel stocks. Here, as I said before, this is a top-down approach. We'll take supply data, and this can be used as a benchmark method. It's very good to verify the results that we can obtain when we take the more granular sectoral approach that I'll be covering now. Here, this approach, we're going to take the known mass of carbon contained in each fuel under a consideration that all carbon is going to be preserved and oxidized. We're going to know the mass of each of different greenhouse gas produced. For this, we're going to need the use of emission factors, which are going to relate the energy used, combusted, to the total mass that is going to be emitted. Here, wait a second, please. Gonna touch again on this sectoral approach and follow up on it, our building blocks are going to be the amount of fuel combusted. For going from this fuel to energy, we're going to need the net calorific values, which are going to allow to convert between these physical to energy units, and which are going to be fuel specific. And finally, the emission factor that I mentioned is going to relate this energy with the mass of gases produced. Here, the IEA, there was a question before related to this. General approach is to take the IPCC default factors for this. And once we have these estimations for each fuel, for each sector, we then can obtain the total fuel combustion emissions at national level. Here, brief touch on an exception is to say for biomass combustion, the CO2 emissions are not included under the energy sector, under the IPCC guidelines, and they are considered in the agriculture, forestry, and other land use sector. Emissions from methane or nitrous oxide should be included under the energy sector. Now we'll cover data quality and why it's key in the estimation of greenhouse gas emissions. Of course, the first step is always national energy statistics and the data collection. And with this, we can elaborate energy statistics at commodity level. And for going from this to energy balance to energy units, we need the net calorific values, which are a key building block. And of course, following a methodology, IRES, as I described before. And once we have this, we are going to be able to, following IPCC guidelines, use these emission factors and go from energy to greenhouse gas emissions. Here, as I said before, net calorific values can also be a source of statistical difference that later can lead to this difference in emissions potentially. So this is always a crucial consideration upstream before estimating greenhouse gas emissions. Another key part of this is following a structured sectoral segmentation. For this, we follow the United Nations ISIC, so also for classification for manufacturing industries. And here you could see that within the energy sector, before we saw there are three categories: fuel combustion, fugitive emissions, and carbon capture and storage. We are focusing on fuel combustion, and within it, we can see there's more disaggregation, and this how we then classify our demand data or the end use sectors. For fugitive emissions, just to touch briefly on it, for example, the emissions covered there would be flaring from gas production, but this we do not cover today. And lastly, the standard international energy product classification, which allows us to have a standard for how we classify different fuels in order to have a constant methodology also in this sense. Now I'm gonna touch on how once we have estimated emissions at national level, how this can be related to other factors at national level. Firstly, what you see here is the CAI identity, which allows to study how different factors are involved in CO2 emissions. In the figure, what you see are indices. And what we can see is how CO2 emissions can be split in different factors. As I said, first would be the population, then the GDP per capita, then the energy intensity of the economy, and finally the carbon intensity of the energy supply. As you can see from the figure, CO2 emissions have been going up, and the two drivers behind this have been population growth and the growth in GDP per capita. Second topic I will touch on is the GHG protocol, and specifically electricity grid emission factors. The GHG protocol separates greenhouse gas emissions in 3 scopes. Here I'll cover 2. The first one would correspond to direct emissions, direct combustion emissions on premise. The second one, which is what I want to touch more on, would correspond to electricity consumption. For estimating emissions from electricity consumption, we need both this value of electricity consumption and then an emission factor for the electricity generation. This factor is estimated based on the different fuels, different technologies involved at national level for electricity generation, and of course varies from country to country. And finally, to touch briefly, if someone would like to expand for scope 3, this would be emissions mainly corresponding to the life cycle. So here, for example, would be in the fuel cycle, so how fuel arrives to the production of electricity, how it's mined, things like this. Wrapping up in some final points. First is that in order to estimate greenhouse gas emissions, the sectoral national energy data are key, and this is the building block for developing sound policy and be able to generate broader energy planning. And coming back to the standards and why the methodology is important, following methodologies that are aligned both for energy statistics and for emissions allows us to have this work aligned between the balances team and the emissions team, of course. And finally, on focus areas on how there can be improvements for this work. First, the timeliness of data collection is always key. Secondly, improving the accuracy and international comparability, which is of course linked to following standards that can make our data comparable with other sources. Here, there's mentions to for product classification, the SIEC and the ISIC, which corresponds to classification of economic sectors. Finally, two last points, ensuring coverage in all demand sectors. And as I mentioned when starting talking about the methodology, ensuring that there's a track of the non-energy use of fuels that should be excluded when estimated energy emissions. We'll now maybe leave some time if there are questions, and then if not, we'll move to some Menti questions. Be prepared.